Assalamualaikum and a very good evening to all the examiners. My name is Muhammad Faris Akbar bin Abdul Muttalib, and today I will like to present my final year project named Automated Watering and Monitoring System for Tomato Plant using Arduino. Without further ado, I would like to start the presentation now. So as for the start, this is the introduction. An adequate water supply is important for plant growth. Due to lack or over amount of water supply will affect the growth and the quality of a plant. Therefore, a solution has been proposed and developed where this project will supply the water automatically according to the plant's needs, and user is able to monitor it using web application. So next is the problem background. The first problem is there's no natural water resources will be a major issue, and also when there is no one to control the pipe manually due to no time and absence of the in-charge staffs, and also the soil moisture cannot be accurately predicted even when the plant has been watered, but due to the weather condition the moisture of soil will also be affected. The aim of this automated watering and monitoring system for tomato plant using Arduino project is to develop a prototype that able to monitor the growth and minimize overwatering, as well as production costs of tomato plant. So this is the objectives of the system, where it investigate the watering and monitoring system for tomato plant using Arduino, to design a prototype called automated watering and monitoring system for tomato plant using Arduino, to avoid waste in watering and less time consuming, as well as reduce the labor cost, to build a hardware part that consists of sensors and Arduino microcontroller, to develop a web application that receives the data from the Arduino and act as the platform to monitor the tomato plant. Lastly is to integrate the sensoring and watering module using Arduino, as well as monitoring module using web application. Next, we will proceed to the scopes of the project. There is two main modules for automated watering and monitoring system for tomato plant using Arduino, which are the software and the hardware modules. By using the web application, the status of the tomato plant can be monitored regularly. This project is implemented based on the soil moisture level, which is according to the tomato plant development stages. The prototype will consist of the hardware module and a plant of tomato. And lastly, the period to start reading the data will be 2 weeks of tomato plant development. The literature review of this project is Agrotini UTM is a project that encourages the staff of University of Indonesia to join the agriculture industry and to have an entrepreneurial mindset aligned with the UTM global plan. Currently, the watering system in agrotani is done manually using the porous pipe. The water plays a very important role in agriculture in producing high quality product. There are many advantages of good irrigation that only supplies water when required. There are two main irrigation systems, which are the sprinkler and drip. So this is the data that has been collected from the stakeholder, where as you can see there is 4 phases of tomato development, which is for the first phase is the seedling phase, which is between the 1st until the 40th day of the tomatoes growth, with ideal moisture percentage at between 60 to 65%. The flowering phase between the 41st day and 65 days, and the ideal moisture percentage is between 70 to 75%. And development of fruit phase between the 66th to 80th day of the tomato growth with same moisture percentage as the phase before. And lastly is the fruit maturation phase, which is between the 81st to 110th day of the tomato growth with 75 to 80% ideal moisture percentage. So next we proceed with the comparison between existing systems. So the first existing system, we have the click and drip irrigation kit, where this kit is able to water the plant using with less waste by connects to a water bag that is included in the kit. And another one is the Hauser Aqua globes, where the user can simply fill the water into the globes and place it in the plant's soil, so that water is able to flow to the roots of the plants. So this is the comparison table between the existing systems and my developed system. So in terms of the features, the first one is it suitable for indoor or outdoor? So for the first click and drip irrigation kit, it is suitable for both. And the Hauser Aqua globes is more suitable for the indoor, and my developed system is suitable for both indoor and outdoor. In terms of the timer, click and drip irrigation user is able to purchase the timer, while the Hauser Aqua globes, there is no timer for the system. And my automated watering and monitoring system will not have the timer, as it depends on the plant's needs, whether it needs to be watered or not. Able to access the system remotely. So both click and drip and Hauser Aqua globes has no application that can be accessed remotely, while mine is able to access to the system by using the web application. There is no sensor used in both of the existing systems, while mine, yes, I do have soil moisture and humidity sensors that will use to gather the environment value by using the controller. So next is the methodology. So as for this project, I used the rapid application development methodology. For this already, the first phase is the requirement of planning phase. This particular phase is used to study on required hardware and software for the development, and also it compares with existing system available. Next, we have the system design, where I have done the requirement analysis, develop a Gantt chart, develop a prototype, as well as the user interfaces design. Once I have managed to complete all the required designs, I proceed with the development, where this developers where I do the coding, and also I find bugs in the system, as well as the prototype testing. And lastly, the cutover phase, where I have done the real testing and the implementation of the system. The technology used for this particular system is the C programming language. It is used to code the hardware parts by using Arduino IDE platform. Second, I used the HTML and JavaScript to develop the front end and back end part of the web application. And lastly, I used the Firebase real-time database by Google to store all the data of the system in the cloud. So these are the list of hardware requirements. As for the main hardware is the Node MCU ASP8266. Node MCU is a microcontroller that will be used to control all other components attached to it. Second is the soil moisture sensor. It detects and measures the soil moisture level. Third is the DHT11 humidity and temperature sensor. Measure the temperature and humidity in surrounding area. Also the water pump to pump the water flows through the plant. Also the DS3231 real-time clock to retrieve the accurate timing. A relay is required as it acts as the bridge between the submersible pump and the microcontroller. And also of course a laptop to prepare the documentation and develop the application. So these are the list of software requirements, where the first I use the Microsoft Windows 10 to install all the required tools in terms of the IDE, also to access to the Firebase console section. Also I use the Microsoft Word 2016 for the project documentation purpose. UMLAT is used to design the unified modeling language designs, and also the Notepad++ to develop a web application by using HTML and JavaScript. So lastly is the Arduino IDE. There is the main compiler for the Arduino microcontroller. So now we'll proceed to the requirement analysis, which for the start is the use case diagram. As you can see, the garden supervisor is able to log in to view soil moisture reading and also get the statistics of the soil moisture reading. Also view temperature and humidity reading, and also get the statistics of the temperature and humidity reading. User is also able to generate the table of report in real time. And lastly, the garden supervisor is able to configure the device according to he or she's preferred settings in terms of the soil moisture ideal reading, and also that when the time of the device to take the sensors reading. So this is the login sequence diagram. As you can see, the garden supervisor has to log in by inserting the username and password, and the controller will validate the username and password from the database, and if the credentials are accurate, the user is able to access to the system. Next is display sensor sequence diagram. So the web application will automatically load all the sensors value by requesting to the database, and it will return each of the sensors reading and display in the web application. This is a display statistics sequence diagram. So the web application will automatically request all the data that have been gathered in the database and display in a line graph on the web application system. And this is the set configuration sequence diagram. So whenever the user wants to enter the new settings for the device, user is able to see the previous setting that has been entered by the user. And also once they have changed the data to a new one, by clicking submit, the user is able to see the new settings in the text box. So this is the activity diagram for the web application, and also the hardware device. So on the left is the web application. So user has to log in first using the email and password in order to access to the dashboard of the system. Once the login is successful, user will be redirected to the system's homepage, where the user is able to view soil moisture, temperature and humidity reading in real time, also generate a table of report, view data statistics, and lastly is to set a new configuration for the device. And also lastly, user is able to log out to back to the login page itself. And on the right part is the activity diagram for the hardware device. So sensor will get the value, soil moisture value, and other sensors as well. And web application retrieve the data from database, and it will display the current soil moisture value. So when the current soil moisture value is lesser than the ideal soil moisture value, then it will water the plant accordingly, or else if the current soil moisture value is more than the ideal value, they will not require to supply the water to the plant. So this is the system architecture. So on the presentation tier, we have a browser, a node MCU, and also other sensors that have been attached on the microcontroller. This particular presentation tier contains the interfaces and to display all the data. User make requests to the system through the user interface. Next, we have the logic tier, which is the internet. It is used to function to process the request from the presentation tier, where it gathers all data and process before store in the database. And lastly, we have the data tier. This is the where is the system database is located. So all the data is stored in cloud database. This tier will respond to the request from the logic tier. So this is the database design of my project. So as you can see on the above part, this is the file-based authentication, where all the email that has been registered to access the system can be seen from this file-based authentication list. And on the bottom left is the settings of the data structured. So we have a solve value, time 1, which is the first time taken of the day, time 2 is second time taken of the day, as well as the time 3, which is the last day of the time taken of the day. So this is the settings that entered by the user according to their own preference. So on the bottom right, we have the sensors structure of data. So every object contains the data that has been uploaded by the hardware device. So as you can see, first we have the status, dry, either dry or wet. So this depends on the soil moisture, current soil moisture reading. Also, the hardware device includes the date that has been retrieved from the real-time clock, as well as all the sensors like humidity, moisture, and temperature. So this is the interfaces design of the web application. So on the above left, we have the dashboard page, where it's a single page that user is able to access to most of the functions of the web application system. On the upper right, we have the report page, where the user is able to see the generated table of report of gathered data in the database. User also able to pick options for the table, like to copy, to save it in a Excel file in CSV format, also is as a PDF file, and as well as directly print the table using a printer. And the bottom picture shows the statistics page of the data that has been gathered in the database. So it will automatically generate all the readings of that have uploaded into the database in real time. So whenever there is a new data that has been uploaded in the database, it will automatically generate the statistics, the line graph. So this is the implementation of the prototype. So as you can see, the microcontroller is powered by a power bank as a power source, where it connects to the relay, and the relay acts as a middle part between the microcontroller and the submersible pump. that will supply the water to the plant, and also the tomato plant that is used as the test case for this prototype. So output of the function. So for the hardware device, we have the push data function, where it will push the data to the Firebase according to the time that has been set by the user, as preferred by the user. And also every time the device has uploaded to the database, the web application will directly update in the system. So this is the functions to display the latest census reading in the web application. So as you can see, this census section has the latest reading of the soil moisture value, the temperature, as well as the humidity. So that the time taken is the date and time that the database has uploaded the data into the device has uploaded the data into the database. Sorry. Okay. So this is the function to draw the graph. So basically I'm using the chart.js to draw the graph. So by getting all those data from the database, it will draw the line graph accordingly. And this is table of report, where I'm captured all those data in the database and also draw it in a table, so that the user is as easily can understand the data that have been gathered in the database. So this is the black box testing. As you can see, there is two black box testing that have been done, which are for first is for the hardware device, and second is for the web application testing. So on the left side we have the hardware device. So basically there are few test data that has been tried on the hardware device. Like first one is the turn on your MCU, and the output will light on the board. The light on the board will turn on, it pass. Second is to check the water pump. It is able to supply water as required to the tomato plant. Third is to check soil moisture sensor. The serial monitors will show the soil moisture reading in percentage. The check humidity sensors. Serial monitors show the humidity reading in percentage. Fifth is the check temperature sensor. It shows the temperature reading in Celsius. System is able to run in 14 days without any issue. And lastly, power shortage. In case of the system has disconnected from the power source, when we connect it again, it will still have the works accordingly as before. So for the web application, the login, so the user credentials has been verified and dashboard page is displayed. Navigation between the web application, it enables to navigate to different pages. Display real-time sensor data. The system is able to get the latest data in real time. Generate a table report. Yes, all the stored data can be displayed in table form, and also the user is able to save as PDF and others options as preferred by them. And also generate a graph of sensor data. Graph can be generated accordingly to the data that has been stored in the database. Change device configuration. User is able to set the soil moisture value to determine the ideal reading to supply the water, and also time to take the census reading. Logout. User will be navigate to the login page whenever he or she clicks on the logout button. Next is the white box testing. So this is for the web application testing. So the first one is the login function, where once the login attempt is verified, the user will be directed to the dashboard page. Second is to display the latest reading in real time. So the output is passed, the user is able to get the latest reading in real time. The third one is the settings that have been that is a function that to submit the new settings by the user into the database, and the output result is yes, the settings that have been entered by the user can be seen on the web application. And lastly, the function to display the table of report. All the stored data can be displayed in table form, and also the user is able to print, to save as PDF and Excel, as well as to copy the table. So this is the hardware device. First, this is the first function is the get sensor function. So the output result is the result is passed, where the output displays temperature value and humidity value. The second function is to get the soil moist. Serial monitor shows the soil moisture reading that has been converted into a percentage format. And the third function is to push the sensors data from the hardware device to the cloud, and the result is all the sensors readings has been uploaded to the cloud platform. And lastly, to supply the water to the plant. This function depends on the current soil moisture reading. Let's say the current soil moisture reading is less than the ideal soil moisture value that has been entered by the user, then it will water the plant accordingly. Or else, if the current soil moisture reading is more than the ideal, then we will not water the plant accordingly. So these are the achievements in PSM2. First, I have managed to achieve the objectives as proposed earlier. Second, the system has been implemented in the cloud, where the user is able to access the web application from anywhere rather than in the local host. And lastly, user has been able to monitor the development of a tomato plant using the web application, and the device is able to supply the water to the tomato plant automatically without having any intervention with the person in order to supply the water. So thank you. Assalamualaikum.